Hello, this side Dr. Alok Singh Chauhan, working as Associate Professor in the Department of Information Technology, ABES Engineering College, Ghaziabad. Today I am going to discuss very important topic in Java, that is multi-threading. The agenda points for today's sessions are: first, I will give a brief introduction of thread, why we need threads. Then I will introduce the concept of multi-threading, life cycle of thread, creating thread, and how can we implement the threads in Java. And finally, I will discuss about the advantages of multi-threading. So let's start the today's session. First, what is thread? In Java, process and threads are two basic units of program execution. A process is a self-contained execution environment, and it can be seen as program or application. In simple words, we can say process is a program at execution. Threads are the segmentation of process. That means a process can contain multiple threads. Thread can be called as lightweight process because thread requires less resources to create and exist in the process, as well as thread share the process resources also. So thread is the smallest unit of Java program execution here. Now, why we need threads? The first, by using threads, we can enhance the parallel processing. We can execute multiple threads simultaneously in parallel. And by using that, we can increase the response to the user because we are executing multiple threads simultaneously. So we can get quick response. And the most important, we can utilize the idle time of CPU because when only one program is running, most of the time CPU become idle. But when we are executing multiple threads simultaneously, so most of the time CPU will engage in executing the threads. So by using threads, we can give maximum utilization of CPU and we can reduce the idle time of CPU. Now, what is multi-threading? Multi-threading in Java is a process of executing multiple processes simultaneously, or we can say executing multiple threads simultaneously. Generally, a program is divided into two or more subprograms, or we can say a process is divided into two or more sub threads, which can be implemented at the same time in parallel. Multiprocessing and multi-threading both are used to achieve multitasking. But to achieve multitasking in Java, generally we prefer multi-threading. Why multi-threading? Because threads are using shared memory area so that we can save the memory area, as well as context switching using threads takes less time as compared to the process. So generally we are using multi-threading in Java to achieve the multitasking. Most of the Java multithreading is used in games and animation where different parts of the program can be run simultaneously in the form of threads. Now, life cycle of thread. As we know, every process have a life cycle. Similarly, here thread has also a life cycle, and thread can be remain in any state. There are 5 states: newborn, runnable, running, locked, and dead. So we can understand with the following diagram very well. So generally, when thread, we create the thread class and object. It is the newborn. That means we have created the class, but it is not run. That is, the program has not started. So this is only the newborn state. But when we using the start method, so thread program go from newborn state to the active thread. That means runnable state. So first thread will go to runnable state. Runnable state means now thread is ready to run, but threads is waiting for their chance, and it is a duty of thread scheduler which can give a chance which thread to be run. So when any thread get chance, it will go running state. So running state means now thread gets CPU to execute. So in running state, thread is now executing its task, and rest threads are waiting in runnable state in the first come first serve, that is queue form. If you want to stop any thread, that means we want to take control from thread as running, we can use yield method. Yield method generally takes control from the running thread and back again into runnable state and wait it in a queue form. Similarly, the next stage is block. If we want to terminate thread temporary, not permanently, we can use the block state. So we can use suspend method, sleep or wait method. So if you are using any of these method, then active thread become idle thread. That means it will go from runnable or running state to the block state. That is not runnable. If you are using suspend method for blocking, then we have to use the resume method to make it active again. If you are using a wait method, then we have to use the notify method to reactivate again. But if you are using sleep method, so sleep method generally take time interval as a parameter. So we have to pass the time in the form of millisecond. Suppose sleep in bracket 1000. So it means after 1000 millisecond, the thread automatically become active without using any other method. But if you want to make uh, any thread permanently dead, then we have to use the stop method. So we can stop method from any state, and after using stop method, the thread will go to dead state. That means it will now killed, or it can be permanently death. There are two types of death here, that is natural death and premature death. So if thread is completed its task and then it go to the dead state, that means it is known as the natural death. But in between, if we got any exception or we want to forcefully stop any thread using stop method, then it is known as the premature. But in dead state, they cannot be reactivated. Simply permanently terminate the thread. So this is the whole life cycle of thread process. Now, how can we create thread? Generally in Java, threads are implemented in the form of objects, because thread is a class which is defined in java.lang package, and thread class have two inbuilt method, that is run and start, which helps to thread implementation. The run method is the heart and soul of any thread because it contains the logic. All the logic are implemented in the run method and it make up the entire body of thread. And the run method can be initiating with the help of start method. So if you want to call run method, we have to use start method here. Now, how can we create thread in Java? There are two different ways of creating thread in Java. First, by extending the thread class. So, and second, by implementing the runnable interface. So, in Java, we can implement the thread by two ways. First, we can extend the inbuilt thread class, which is defined in java.lang. Second, we can implement the runnable interface, which is also defined in java.lang package. So let's take example. First example, how can we create thread by extending the thread class? So here we have to use the extends keyword and thread class. So here class, we have create class example our and extends thread. So this is extending the thread class. Then we have to define the run method. We have to declare the run method and we can give the body or logic of the method. Then in the main method, we have to create the object of this class. Example t is equal to new example. That means we instantiated the object. And after that, we have to call the start method. When we write here t.start, that means it will call the run method and we can get the output like welcome to ABES. So here the start method is used to call the run method, which is defined our in thread. So this is example how can we create the thread using the extending the thread class. Similarly, the another way we can also create the thread by implementing the runnable interface. In that case, we have to implement keyword. So class will implement the runnable interface. As we already know, in any class we have used extends, and for interface we are using implements. And run method is the same logic. But the difference is that when we create the object of this class demo d is equal to new demo, we cannot call the start method. Why? there's a difference between thread class and runner interface. Thread class contain two methods, that is the run and start. But runnable interface contains only one method, it is run. It doesn't contain the start method. So for that, to run this program, we have to make first thread class object like this, thread t is equal to new thread, and we have to pass this object into thread class. Then we can call the start method. So this is the process indirectly. So first we have to create the object of this class demo, and we have to pass this object into thread class object, that is the object initiated for thread. And then we can start method. We can use start method. This is a difference, and output will be the same, but the difference of creating the uh, runnable interface and implementing, there are two difference. First, we have to write here instead of extends, we have to implement runnable, and we have to make the thread class object for running the runnable interface program. In this example, I have given only one class, but we can also use multiple classes as a multiple thread. So I can give an example where we can use multiple classes in a same program for multithreading. So first I am taking example of extending the thread class. You can see this. Here we are using three class. First class A, extend thread, and we are using run method, and we are giving one loop, I is equal to 1, I less than equal to 5, I plus plus, and we are printing thread A with the different value of I, like 1, 2, 3, 4, 5. Similar logic, we are using another class, class B, with different variable J and thread B. And similar logic, we are using another class C with different variable K and thread C. So these are three classes, class A, class B, and class C. All these classes, three classes extend the thread. Now, after making logic, we have to make the object of this. So first, we are using the main method where we can make the object of three, that is A, B, and C. Three objects are created. It is like treated as a three threads, and now we can run simultaneously A dot start, B dot start, C dot start. That means all the threads are now started in parallel. So we can give we can see the output of this program by using the command line screen. So I can uh, run this program using the command line argument. So we can see the output here, the command line screen where we can run the program. So we can see here, first we have to write Java C, that is for Java compilation, and program name I have saved at example.java, because generally we save the program with name which contains the main method. So now we compile the program and there is no error. Now we can run with the help of Java interpreter, and we can see here the output like this here. So all the three classes are running simultaneously. The main point is that the output will be depend upon the CPU, because every time CPU can allocate the different time counter to the sources. So it depend upon CPU. If we run again, we can give a different output. So it's only depend upon the CPU, but the main objective is that we have to implement the all the threads parallel. We can do this like that. Similarly, same program can be implemented using the runnable interface also. So you can see here, this is the program where we are using same program. Only difference that now we are using runnable interface. So instead of extend thread, we are writing here implements runnable, and the same logic, void run same logic, A same, class B same logic, same program. But the difference that instead of extend thread, we are using implements runnable, and in the main method we have create first object of three classes, class A, B, and C. Now we know we cannot directly run the start method using this object ABC. So first we have to create the objects of thread class, thread T1 where we pass the class A object, then thread T2 we have passed the object of class B, thread T3 where we have passed the object of class C. Now we can start T1 dot start, T2 dot end, T3 start. So it will call the run method. So this is basic difference in these both program. First we have to write implements runnable instead of extend thread, And second, first we have to create object of this class and pass these objects into the thread class, and then we can call the start method with the objects of thread. So I can also run this program. You can see in the command line screen, you can see here how can we run this program. So the program name is demo.java. So we have compiled this program with demo.java. So it compiled successfully. Now we can run this program and we can get the output. So we can see all the classes in the form of threads are running simultaneously. So this is how we can run the multiple threads simultaneously, either with the help of extending thread class or implements the runnable method. So this is how we can implement more than one classes also in the form of thread using either extend thread or runnable interface. Now, what are the advantages of multithreading? The first, it doesn't block the user because threads are independent and it doesn't affect the other program. So user can run multiple programs simultaneously, and also it can perform many operations together. So it saves time also, and threads are independent, so it doesn't affect the other thread. So if any exception is coming any one class of thread, it will not affect the other classes. So all the other classes can run very easily. So threads are independent. Okay, so this is the advantage of multi-threading. You can run the program without affecting the other threads and without blocking the user. I have used the following references for the multi-threading concept. So that's all for today. I hope you have understanding of now what is thread, what is process, what is multi-threading, why we need threads and multi-threading, and how can we create threads using either extend the thread class or implement the runnable interface, and what are the advantages of multi-threading. So that's all for today. Thank you.